program director of design and innovation and creative engineering, which we call DICE. And actually the kind of focus is on getting students to generate extraordinary ideas and then putting them to work. So at university, no student would call me Dr. Shoup. They would just call me Karen. So it's quite different, say, for when you're at school. So I'm getting the best way, to tell DICE, I think, is through our students. So I really love this picture. So this was just a few years ago. It was a hack event between Deloitte and the National Gallery, and they wanted to see why younger people weren't attending the gallery, what they could do to get younger people to attend. And I love this because it really doesn't look like a group of engineering students, because I think of my students partly as engineering students and partly as design students. And they were, they're obviously delighted to have won, but they were really shocked to have won, because they said, we don't understand why we won. There were these groups who had computer scientists and they were making the tech. And I said, but that's why you won, because people like Deloitte can employ people who are really good at creating tech. But why they wanted designers to come in was to try and identify what the problem really was. And the problem with most of the other groups is they jumped straight into a solution. And what this group did was sit and think, well, what is the problem? Why don't people their age, student age, why don't they go to the National Gallery? And they said one thing, actually, people don't really understand the stories in lots of these classical paintings. So they thought about, actually, ultimately their solution would have augmented reality, would have AR, but they'd be able to overlay the story, which would make sense to them. So the fact that they didn't rush to solution, the fact that they looked at a problem before then saying, well, this could be a tech solution, was really, Deloitte were really excited about it and invited them to another hack. So if I go from left, that's Nicole, and we're going to see her in the next slide. She is director of product at Hackmasters, who's one of our hosts for a final year project. And then Celia, second left, she went to Copenhagen after the DICE degree to do a sort of design and innovation masters. And then Audrina, at the moment, she's saving up to do a master's, but she's doing graphic design and some user interface design. And Ruby on the right has been working with her host for London Air Ambulance from her final year project. So working as a designer at the interface between design and medicine. So this was a picture which was sent to me last week. So there's Nicole at the front, who is now working for this company called Hackmasters. And then the student next to her, Sarah, and the student at the back, Zaina, they're final year students at DICE. So the host of our company from Hackmasters came along and met the students for the first time. He said, well, I'm having a hack event in Dubai and I'd like to take some of your students there. So this was all expenses paid. It wasn't, they didn't stay in kind of top-notch hotel, but this was kind of within a week. He'd met our students and flown 2 of our students out to Dubai to take part in a hack. And the student in between, so the student wearing the all black top, that's Shraddha, who graduated last summer. So she didn't do a project with this host Hackmasters, but since graduating from Queen Mary, with a very good first, she's worked with Hackmasters, and this is her second hack with them. So that's kind of 3 different cohorts of our DICE students meeting up in Dubai. And that was just last week. And then there's Sarah and Zaina being incapable of holding something the right way up, so as engineers. And that's them having won an award, the Ecology Prize, as part of this hack event. No, you're not going to hear the noise. I can hear it, apparently. This is the London Air Ambulance, and this was taken from one time where we went there because about 2 weeks ago, some of our final year students went to the London Air Ambulance. We went to see some of the training, and then quite luckily the ambulance was coming in, so we got to see it land. And in this is the previous year, we got to see it take off, because Sami, who's one of the medics at the London Air Ambulance, he wanted to see what happened when designers come to emergency medicine, that we could step back and look at the situation and use part of engineering skill and part of a design skill to identify where there are problems. So it's not the case where they go along, apart from one example, with a medic saying, I need you to solve this. This is the students coming along and saying, but why do you do this? And why does this take so much time? So we have, this is again another host project with industry in the final year, and students get to go. So it's just down the road from Queen Mary. And this is the Raboa bag. So this is a bag created by one of our students. And that might seem just quite trivial, like why would you need to be a designer? Why would you need engineering skills? But Hal came along and he looked at this very, very complex procedure where at that point only 17% of people were surviving. These are people who are usually so ill they never get to go to A&E. And he said, I can't believe you're using this bag. He saw that there was a huge cognitive overhead of people having to remember things and then having to root around the bag to try and find the necessary equipment when time really costs lives. So he took the metaphor as of the book and said, well, actually, at the beginning, you need this, and then you need this, and then you need this. And at this point, you need this knowledge. So why should it be in your head? Why can't it be there in a really simple form? And I'll show you later on the final student version, and that will show the difference really between a student working prototype, and then this went through many versions to pre-production prototype. This is on the London Air Ambulance, but it's also on air ambulances around the world. So when Hal came to Queen Mary, he knew nothing about medicine, and there's no way that he would have thought that his final year project would lead to, would be on air ambulances internationally. And then lastly, this is something we did quite recently with our final year students when we were looking at, it's really what you might call human factor design. So looking at artifacts and then what's called designing for empathy. So creating empathy tools to try and think, well, okay, if somebody had arthritis, if somebody had a shoulder operation, if somebody had certain conditions, what's wrong with these everyday gadgets? So it might not be clear, but the object on the right is an iron, and the students went into our makerspace and sawed the iron to get to the form that they wanted. And likewise, the kettle, they used a saw to cut it down. And this was after having covered it with Post-it notes to try and identify what was good from a design perspective or an engineering perspective, what wasn't so effective. And that way you can get to understand and actually start to hack objects and see what the problem is. So what do students actually do on the degree? So what makes DICE really interesting is the core of Design Studio, which goes throughout, and I'm just going to look at the 3-year degree in this talk. And then it's balanced by engineering modules, by materials modules, materials science engineering, and then the creative tech module. So this is the current syllabus that the first year students are going through. So in the first year in Design Studio, it's about discovering who you are as somebody who creates. How do you make decisions? How do you take an idea, and not the thing we're focusing with our first year students at the moment is, okay, you've had a good idea, but that's your first idea. And your first idea is never your best idea. So how are you brave enough to put your first really quite exciting idea aside and start pushing through other ideas? How do you take 2 ideas or 3 ideas and synthesize them, not merely just collide them? How do you actually push an idea forward through sketching, through mock-ups or sketch models, through to a more refined prototype? And then bit by bit, we add more constraints, we add mechanism, material, functionality, and so forth. So alongside that, you're doing the engineering design, which is obviously things like CAD, and some case studies, and some other sort of workshop maker skills. Then the statics and the dynamics. So this is engineering, but engineering the maths taught together, but not just as a step-by-step procedures. It's really understanding the engineering maths conceptually, as you would need to do when you get to industry. And then the creative tech modules. So I used to just show examples of products, but in fact, what was useful was the feedback we got from the students to give you a sense of what happens, the shift from A-level. So there was one point where students said, oh, at A-level, we would say for A-level art, we'd take 3 artists and we'd take a bit and then we would jam it together and that would be ours. And it's like, no, that is A-level. Now you've got to use your own judgment. You've got to push your ideas further. And you just can't stick with your first idea. you've got to go exploring and taking risks and realizing that sometimes, you lose some things as you push something further. Sometimes you need to bring your engineering skills in. Sometimes you need to push the engineering skills back to be able to explore in a bit more of an experimental way. Then we get to year 2. So on the picture shows our maker space. So it's an L-shaped space. And in fact, these are DICE students in the days when you used to have to wear lab coats. We decided lab coats really aren't what you need in a maker space. So now that we're much nicer aprons. So this is just for the machine tools. The hand tools and the sort of gluing and 3D printing and so forth. Then within this creative hub, so the other side of this L-shaped room is a machine tools room. So students go through a separate induction for that. And then across the corridor is our design studio, which only the DICE students have. So we're the only students who have their own base. So even though I was working with second year students and third year students today, one of the first year students wanted to continue working on a project. So we found space for him. So he actually then gets to see what goes on in second and third year. By the second year, you're now ready to look at something more like design. So that's where we start to think about users, usability, and interaction. Because the first year, you really thought about how do you function as a designer, as a creative. And then in the second year is when you start to get the more advanced sort of materials and engineering modules, which build on the early skills. Now, what you'll notice, not just at Queen Mary, but as you go to other universities, sometimes the title doesn't sound like engineering, but designing for manufacture is an engineering module. Obviously, materials for sustainability is more of the kind of material science engineering side. Then in the creative tech world, what we introduce students to is Arduino, which is a microcontroller, so that students can add sensors or actuators to their artifacts. So you could respond to proximity, or it could be a linear potentiometer would be as your finger goes up and down the sensor. It could be piezoresistance, so more a sort of squeeze or pressure. It could be light. It could just be the yellow light. It could be sound as your sensor, and then you can have motors, you can have lights, you can have a whole range of different actuators in response. So here just is an example of year 2 design studio. So we really encourage rough sketching, because if you leap straight to CAD, so we actually remove CAD in design studio in the first year. You do it in design engineering, but not in our design studio. I'm just seeing something. And we want you to sketch, because when you sketch, if something's wrong, you can throw it away. You're prepared to go and modify it. Once people go into CAD, once they go into 3D printing, they don't really change their ideas. So the picture in the middle, people were trying to work out, this is kind of some of the sketch model behind, at the same time they're working out the torque and so forth for the rotation within the light. But at the bottom right, we've got rough cardboard modeling before you go to more advanced modeling. Then here's some more second year design studios. So in the left, this was using some Arduino. So the student was really interested in non-verbal interaction. And so this system moved in response to but in a slightly more arbitrary way, to when people spoke, because there's a little microphone in the hand, which is up like that. There's some rough making on the right-hand side. These are really rough sketch models. The student was looking at if you're using drawing tools in 3D, well, you don't want the mouse on the table, so how could you push that further? Bottom right, student were looking at how can you redefine space to encourage socialization, or actually to say, no, I don't want to socialize. One student was interested in different ways of storing liquid, when you're kind of in more mobile situations where you wanted smaller containers. And one student was interested in teaching spice, teaching the beginning and sort of cooking. Then in creating interactive objects, this is the course which introduces the Arduino. So Frank is using, there's a linear potentiometer in his sort of violin device, but Hal in the bottom right, it's part of an umbrella that responded to levels of moisture. So here he's prototyping some of the kind of basic ideas. And then bottom left, it was a game. So it was superhero moves and a target. And depending which move you made, it kind of generated different sounds. And then this was last year where they were looking at essentially a digital twin, because at Queen Mary there's lots of green spaces, which lots of staff and more so the students are unaware of. So one had a sort of map that you could interact with. One was looking at the levels of pollution on campus. There's another one. There were about 6 or 7 projects. One was looking at sounds on campus, but instead of doing the obvious sounds, they recorded above the canal, because we've got a canal at one end of the campus, below the canal, and then inside these black plane trees, which are very, very rare. And I think the black plane trees in London might be unique to Queen Mary. So the idea there was a radio, but the sounds were the sounds of the campus. And this is run by a professor from our electronic engineering and computer science school, but he's actually a psychologist. And so there was a sustainability in the curriculum network meeting, and this was presented to them. And the idea is actually they're hoping that they can present this at a London-wide student conference on sustainability. These are more creative projects. Again, I wanted to show kind of some people were using more sort of engineering drawing skills. There's the Arduino circuit. Just for kind of another group looking at interaction, so trying to explore interaction in an architect's office. But what I like at the bottom left is just an example of a student group. So Sophia came from Norway, Tokus, and she now works for IBM, which sounds like boring grey boxes, but actually is design-led. I mean, it's a complete design thinking right from the beginning, a really sort of strategic approach to design. So she works as a design researcher for them. Tokusa is working as a games, I'm not just a games developer, as a games designer, but he's working in the games industry. Frank's doing a master's in product design engineering, and Neve is working in a tech telecoms, I think, or communication tech company in Thailand. Frank's from Poland, Neve's from Thailand. Tokus is London, Sophia's Norway. Then we got our so I'm thinking of year 3 as the final year. That is an MEng. I'm going to focus on the BEng. So 2 big projects. One, your individual one, and this is where students have got to focus on a problem. So this is what students are doing at the moment. This first semester, it's not, this is my solution or my concept or my product. This is, what is the problem? There is no point solving a problem if it's the wrong problem. It's not just us who say it, it's kind of D School in Stanford who say it, IDEO, the big design consultancy. So this is the approach we want in design thinking. Don't rush to solution. I think that makes the students very strong, depending whether or not they go to design engineering afterwards, or various areas of design, or in fact, people go on to strategy. And then our group projects with industry. And then there's the sustainability assessment for design is an engineering module, but kind of looking at aspects of sustainability in the life cycle. And then we've got a very, very good robotics group. So they work with bioengineering and robotics students. And then the design for human interaction looks at human to human interaction, and it really helps underpin their design projects. So again, thinking what students said about this. So one year said, well, it's quite scary because it's a whole long design project. In your first year, you have 4. In your second year, you have 2. And now it's a year-long group and a year-long individual. But, it's there with support. So we're going through, the early weeks now, what are students' areas, but we share it as a group, because another student said, oh yeah, I feel this, or no, I don't do this, or actually, have you looked at? We've got the students also become experts, so they can help each other. And so that works very, very effectively. So freedom is scary, but freedom's really exciting. And then I'm just sort of putting ideas to work. Here is Hal. So this is the bag. So in the middle photo, just in the right, you can see the blue bag and the R of Raboa. That's the final bag. But on the far left, it's the student final project. So students are often saying, oh, I want to do a pre-production prototype. But that's a much further stage along in the design process. There's many stages before you have to think of some of the qualities of pre-production. If you rush to that, then you miss out on some of the critical design thinking that makes you an interesting and employable designer or design engineer. So his early project still had a long way to go. It was never going to be robust enough to, it's not just that it's thrown onto the ambulance, but they get off the ambulance, they have to sometimes climb over fences and kind of go through doorways carrying multiple bags, dump it on the ground. It's got to be really robust. And then Hal at the top and the left is talking to, on the right, Sammy, who is the medic we work with, who students meet on a sort of fairly regular basis in their final year. So this year we've actually got 2 group projects working with Sammy and hopefully 2 individual students. And this is the 6th year of our relationship with the London Air Ambulance. And we're also trying to set up a medical design hub. So joint with Queen Mary and the London Air Ambulance, and also bringing in A&E, so the emergency medicine at the Royal London Hospital, so that we can bring in the needs of medics and the skills of our design students. And I don't think there's anywhere else in England, possibly in the UK, which has got that sort of relationship with medicine, and certainly none others which work with an air ambulance. So here's one of the projects from last year. So Shraddha, who was 3rd along in the picture from Dubai, this was her project. So she looked at, on the far left, this was the existing bag, and it was, it's got too many things in the wrong place. And on one level, well, you also have to look at things from a psychological perspective. When they come to the emergency, the process of putting things out, partly you need it to be slow because it calms everyone down. Even in an emergency, you need some headspace. But at that point, you then don't have to want to waste time trying to find things. Somebody had worked in the past and had come with a special mat, but it was far too prescriptive. And then you had to, where does this go on the mat? It actually caused more time. And Shraddha, as part of her process, she looked at everything in the bag and she made a model of everything in the bag, so that she then had a way, like, how do I redefine the use of space? And hopefully this is ongoing with the London Air Ambulance. This was a student who looked at nursing homes. There's a lot of tech. It's very expensive and it goes wrong and requires a lot of maintenance. So he wanted a more straightforward solution looking at falls. So initially there was can you prevent falls? And then actually, what were the implications? If you prevented a fall, then you were trapping somebody in bed. So how would we have a call monitoring system? So went through lots of some flow diagrams. It went through lots of systems. It was like, there's 2 buttons. One's emergency and one's not so emergency. And we were like, well, okay, but you've just fallen over. That's an emergency to you. You're not going to I'm going to let everyone else. And what if you know that your friends always press the emergency button? Why would you press the it's not so important? If you are old, or for anyone, if you fall out of bed, that's your own personal emergency. So you have to really think carefully about how to model things. So it went through, we had a kind of what looks like prototype, a working prototype, and he's kind of presented it to some companies who are interested. Again, there's some working towards a looks like, but definitely a sort of works like prototype. Student was interested in haptic time measurement. So this was looking at a situation when you can't see. That could be that you can't see because of sight impairment, but it could be that you can't see because it's very dark, or it could be that you can't see because you're a psychologist with a client and you can't be seen to look at your watch because that looks like, if you're looking at the watch, it's when is this going to be over? It, to some people, might send the wrong signal. So here's could we explore this haptically? So on the far right, this was using vibration. So I'm just having a look at the Q&A in case there's anything urgent. So I'm going to answer the questions at the end. So I'm just going back to, let's see if I can get back to the haptic project. So he's looking at different ways, and it went through different shapes, because initially it was shaped like a watch, but actually if we're taking away vision, then we didn't have to have this. So it's gone through different ways of, and there still would be more to go about how sensitive people are, but there are some really interesting ideas there by Mackie. And then this was Julia, and this was one where actually this was given by a medic from London Air Ambulance, who said, well, if you're in a hospital, we often reuse your blood, and there'd be a machine for filtering. but it's a big machine, it's got to be plugged in. The ambulance doesn't have much space, can't have anything heavy, and obviously you can't plug things in. So she looked at how to hack an existing device to have filtration. And after this, it's not just that the London Air Ambulance are interested in it, but the Defence Force, some of the defence area are interested because, well, it could be in a war situation, but it could also be in humanitarian relief where you don't have lots of stacks of blood. So you've got to go and try and recycle blood. Then this was another one with the London Air Ambulance. So this student, Lucia, is interesting because after this, she went to do a biomedical engineering master's at Imperial. And when I spoke to her when she was on the course to see how it was going, and I was like, yeah, how is it? Because she's obviously not doing just a straight biomed degree or a straight engineering degree. And she said none of them know how to design. So she knew the sense that, yes, she had her engineering skills, but she had this sort of special skill, which meant that she was stronger at being able to approach problems and actually really interrogate a problem before that leaped to solution. So here she was looking at trying to reduce the number of monitors on the field. So there's all the exploration work that goes on when you are a student, from sort of sketches. So at the bottom, it's a student looking at, well, most chairs think about keeping you, the idea tends to be keeping you upright, supporting your back. But what if you're in a job where you have to work forward? So I think her father was an architect or a graphic designer. Nicole, I think it was project above, when she was looking at how to kind of issues around condensation and mold in bathrooms, but not using a dehumidifier. Could you have a more kind of tech simple solution? And she was looking at some of the sort of knitted material analysis at Queen Mary. Top right, there was a student who was looking at ways in the beauty industry that there are lots of bottles where you have to push things to mix the liquids at a time, but these bottles use a lot of plastic. They can only be used once. So he was looking at ways that maybe you'd be able to reinsert products. And with that, he's continued working with a company after that. There's at the middle right, that's a London Air Ambulance. Bottom right, person was looking at scent to try and change space. And what was interesting, he had an idea at the moment, was really excited, and then he went to talk to a perfume company, and they were like, no, everyone's thought of that. Everyone's explored that. It doesn't work. Now, he could have, as a designer, one way is to say, well, it didn't work because maybe they approached it in the wrong way. But also as a designer to be able to go, okay, my first instinct was wrong, but I've learned something from that. And also I've got some tips for something else. And then the one which kind of looks Dieter Rams influenced, the sort of white thing, is a light, but it was based on the Pomodoro method, which this student used to try and help him concentrate when he was working. But because it was going more to a Dieter Rams aesthetic, then we had to kind of focus much more on how little could you get a button to tell a user, but it still was absolutely intuitive to a user. So those are the individual projects. We've got the group projects with industry. So Hackmasters, they tend to work with really big companies. So they work with government, they work with the UK government. So in fact, I should have included a photo of Nicole, who you saw winning a prize, who you saw in Dubai. I should have included a photo of her at number 10 Downing Street with Sahar, because the work they do is in the center of government, but they work with governments around the world. They work the scale they work at in new cities, new airports. And often the work that the students are doing, the students are like, why are we doing Mars? Why are we doing Future of the City? And then 6 months later, or 8 months later, I see it in the Evening Standard, I see it in other areas. Sometimes it really is that speculation ahead. And sometimes if you're quite provocative, and at the moment our students are working 30 years ahead, it really tests assumptions you make about life now. So it's a really good design and design principles. And quite a lot of our students have gone, two have had kind of official long-term jobs, but they've had internships and projects and hacks. So Dubai you saw, but Shanghai. One of our students went to Lithuania. We had students going to America, and some of them were afterwards, but some of them were while they were still students. Not quite as immediate as the kind of Dubai thing that happened last week. And then this year we've got students working on what's called the Institutional Memory Project in the sort of A&E at London Royal London Hospital, as well as the London Air Ambulance. The expertise that people have which when you're in a very busy department can notice problems where somebody who's new might be much more, okay, this is the textbook presentation. And it's not, ultimately, you might need, there may be a role for computer scientists to go and do some of the database work, but you need people with a design head to come in and say, but how do we, where really is the problem, and how do we communicate with other people who are having lots of training? They're overwhelmed by the amount of information they're dealing with. They're on quite short rotations if they're junior doctors, and they're seeing loads and loads of patients. So how do you understand the person behind the problem? So again, this is actually a different host. These were projects looking at knee implants for Dupuy, part of Johnson & Johnson, and looking away that if you read, as like most medical tools weren't designed, they were just developed, and the assumption is that men were using them. But actually, if you start to think about, there's lots more female surgeons. If something's more comfortable for a female surgeon, it'll be more comfortable for many surgeons. Then in terms of student experience, so this is the L shape of our design studio. That's of our makerspace. That's used by people in design studio, for DICE students, but also all the students on the engineering design. So for engineering design, say they have a lecture, they have IT classes where we're doing CAD. They've got seminars, and then they'll use the workshop for the induction. To understand some of the maker skills. So they're busy, students are busy in lectures. So lectures will always be recorded. So if you're ill, you can catch up on that. And if you made some notes, but it's quite difficult to listen and make notes. So if you look at your notes like, I don't know what that means. Yes, you may have their slides should be available online if the lecture uses slides. I don't use slides for my lectures. But then you can watch back a recording, and maybe when you're revising. So we see recording, so you attend the lectures in person, but you've got some recording as a fallback if you've been ill. It's not a don't turn up to any lectures and then try and kind of squeeze together lots of lectures. We have tutorials, we have classes, we have labs and so forth. So all for design studio, they're all tutorials. You have an advisor who sees you to kind of check on things, are things working academically, but pastoral support. And then you're just busy working. Maybe you're working on a practical project, maybe you're making prototypes, maybe you're sketching, but maybe you're doing some lab work. So I teach creative coding, so my students, most of them, the lab isn't sufficient to do the lab exercises, and I expect them to work outside the lab. I also have a tutorial, which is, okay, what didn't you understand in the lab? And we work through the answers there. And then the work you're doing, some is what we call formative. So one of the design projects in the first year, you don't get any marks, but you do have to include it in your portfolio. My labs are formative. They're not, sometimes formative might be assessment, you get feedback. Sometimes it's just, you've got to do this. More often it's summative. Some courses have exams. And this semester of exams are in January. Next semester, the exams are in May and June. But more often, there's kind of more of an increasing focus on getting you to do assignments, because exams really work for some subjects, but they're less effective to actually check that you understand the subject. This is a slide there. This is one slide which isn't mine. They made me put it in. What is a little bit disappointing for me for the DICE students this year is that normally I could say at least 50% of my students are female in DICE. It's a bit unusual this year. We've just had a new student, so it possibly has gone up from, when I last checked, it was about 35%, might be a little bit higher, but for me, that's low. But I still, we need more female engineers. We've only got 16.5%. So 26% is an improvement on the national average, but we've still got a way to go. But what's quite interesting from DICE students, DICE is a small cohort, which means they tend to know the second year students, the third year students, and we can get to share their expertise and their interests. But they go from the small classes to these very large classes, which might be, which are shared with, say, the mechanical engineering and aero, the really big courses, and then they can go back to the smaller classes. So they benefit from sharing with kind of aero students and robotics students and biomed students, mechanical students. So often they group work in other courses. They try and spread the DICE students out, because my students are very articulate and come up with lots of ideas. So they want them to kind of work with the other students, but you can kind of move between the two sets of students. I love this quote. It's from one of my students, Caroline. So Gravity Industries, who design flying suits, advertised for an engineer. And she wrote to them saying, you don't need an engineer, you need me. And she said that when she worked for them and they had some engineering interns from Bristol University, she said it was so annoying. She'd say, well, I want you to do this. And they say it can't be done. And she says, well, I know it can't be done, but I need you to understand why it can't be done and what you can think of as a result. And she's like, oh, engineering, straight engineering, very closed, but if you kind of give them enough design, they can be much more experimental. On the right, so DICE, the earlier version of DICE was called Design and Innovation, and this is the Make-U form bot from one of the previous students, so that you can do, so it's a form bot, it's tabletop sort of, so yes, there's 3D printing, but actually you can do some form casting. So Gravity Industry, so Caroline, that's one on the left. So, and one time I was teaching out in China and came to my hotel room and turned on the BBC and they showed the flying suit and I could see Caroline kind of front of the group of people cheering it on. So that was her graduate job. She now works in user experience design. Ada, who's a bit of star on the right. So when she first started on DICE, she's like, but I need to know. She was like, but what do I do next? You just give me more questions. And I'm like, yes, but if we tell you what to do next, we're not helping you become a designer. We're telling you what to do. That's fine for school. That's fine for school. You've got consistent for marking across thousands of students. We need you to make these decisions. By the end, I think she got the top grade in her project. She's an experienced designer, but she's won this thing for a top kind of designer. There was the Beamer Award for top 100. She set up Identity 2.0, which looks at surveillance, privacy, race, and technology. And they do really interesting projects. So she's done keynote speeches at Oxford University, at MIT. She's featured in sort of Marie Claire magazine. So her influence has gone really wide. Our students go to a range of places. So actually here I've got a bit of combination of design and innovation and the DICE students. I mean, there are engineering, but more sort of engineering designer roles really. But quite a few design roles, but also interestingly that because of this design thinking approach, that people have kind of gone into much more sort of analyst roles and strategic consultant. In fact, one of the graduates from last year, he's become a law tech graduate analyst. So that's what we call a magic circle law firm. They're like the biggest law firms in the country who pay an astonishing amount, even when you're studying with them. So yeah, it's a complete range of areas. Like 2 years ago, one of our really good students is working for a snow sports company in Austria. So it's quite interesting when your degree has a strange title and you think, oh, well, people think I'm an engineer, or they think I'm a designer. What will they just think I'm neither? Is to see that students can go into a range of industries. And I like telling the story in some ways through Kamsi, because rather unexpectedly, Kamsi asked us to look at the portfolio. So we arranged a meeting of him, the academics and other students, so we could all give feedback about his portfolio. And we'd assumed that he would, so Kamsi's on the left in the photo, we assumed he was going for a design job, but he went to Berenberg, which is the second oldest bank in Europe, on their graduate scheme. But he used his CV, which would be extraordinary because most people don't usually put design work, and most designers and engineers don't. Well, actually, lots of engineers go into the city, but it's unusual for a designer. So we thought that was, we thought it was a shame. He's a very good designer, but wonderful because he's found an interesting job. And then we got this message. Well, first of all, we got the message he was applying, but there's a very, very good master's at the Royal College of Art. So you get two masters. You get an MA from the Royal College of Art, which is postgrad only, and you get an MSc from Imperial. And it's a 2-year master's, and it's a fantastic route for our students. So after 2 years of experience in the sort of banking tech world, he's now bringing that expertise plus his design skills to his masters. And I love the fact he said to keep the DICE flag flying. He was a fantastic student. And so, yeah, so we've had students go to the innovation design and engineering, and in fact, one student turned it down, which I think they're a bit shocked about. And they used to have an interaction design where we sent students. So Lucia, biomedical engineering at Imperial. We've had the engineering of innovation and entrepreneurship, and that's interesting because it's a proper engineering master's and it's a proper management master's. And I think one of my current final year students wants to do that. Esmeralda, who went to UCL for computing and robotics, then came to Queen Mary to do some robotics research, and then became a design engineer at Arrival, which is a smart transport company. UAL does a really good 2 years master's in materials futures. So one of the students went on, and I've just noticed that my laptop doesn't seem to be charging. And I'm hoping that's better. All right, that's better. It's not going to die. And who is it talking about? Oh yeah, she's working with actually trying to find ways to process crisp packets in a more sustainable way. So Martin's gone to robotics. Frank went to product design engineering. So you can see that some students go down more a tech route and a robotics route. So, smart building and digital engineering, sort of the crossover. Then biomedical engineering, but some have gone more down a design route. So the design and innovation, 2 students went to that master's at Copenhagen. One went to the University of Pennsylvania, but also entrepreneurship. That's just a shot of our design studio. And in fact, that cuddly toy, if you flash a card against it, if you're not the right person, it makes a noise and flashes up. You can't get in. Otherwise, the screen shows that you're let in. Okay, so I'm going to look at questions that computational maths modeling. It sounds complicated. It's got a complicated title. What used to happen is we had an engineering mechanics and a sort of a more maths material. So there were 2 maths modules. But actually, when you would be doing maths now in industry, quite a lot of time you would be using some aspects of languages like Python, which have what I would in some ways call Lego programming, where you've got some libraries which already do some of the work for you. So knowing when you need the fundamentals of the maths, knowing how you can do this computationally, but knowing how maths relates to engineering problems. So not like, oh, when you have this problem, go step 1, step 2, step 3, step 4, which is, I was really upset when a student told me that's how he was taught in A-level maths. It's like, no, that's not, that has changed. It's actually thinking of maths as a concept, maths as it relates to engineering problems, how, some of the kind of core maths behind it, but actually how you would solve it computationally, as in there is some code which is there, which does it for you. So with this degree, you can come in just with maths or just with physics or with both. So sometimes it hasn't happened this year. Last year, the students who just did maths panicked in week 1 because they said, oh, but we haven't done the physics. And the ones who had just done physics panicked in the other week because they hadn't, we haven't done the maths. But after that initial panic, they realized that they could do it. There's also extra academics provided by support. There's what's called the PASS scheme, where students help students. And often students are best placed because they worked through the problems. They see it through a student eye. But I haven't seen that as a problem for the students. And most of my students do really well. And some of them absolutely love it because they come, with their engineering hat on, loving maths or loving physics. So do end up doing a lot of raw maths and physics. So you've got those 2 computational, so those ones have the maths and physics, but it will come in other modules. I'm so not from that side. So in design, I don't have any official bit where we'll be focusing more on some of the design aspect, but every so often I have to go to a student. But where's the engineering maths behind this? I need to get you to explain how this works. So I will get them to pull in that from another side. They can't say, here's an engineering box and here's a design box. So, and in some of their projects, they've had to bring in some of that expertise. And sometimes, say for some fluid dynamics, which students didn't have, one of the profs came along and talked the student through it because he needed it in his project. So sometimes they've got it from a course, but we're in a sea of engineers and material scientists. So again, sometimes I had to go, but where's the material science behind this? So it's not, so exam questions will be, as in, I mean, definitely the computational maths courses, they have exams, but the coursework will also be, I know certainly there's a sort of, sometimes there's a bit of coding for one of their courses, but the other might be more of a maths problem. Engineering design has a sort of problem that you've got to solve, but using some engineering design skills. I'm not sure, let's say, that would necessarily bring in some of the maths, but certainly some of the students today were talking about, they were discussing cobalt and things, so they were discussing, in fact, some aspects of material science for modules. So it's a mix. Do we have a year in industry? So I'm answering verbally rather than typing. I'm hoping that's okay. Do we have a year in industry? No, we don't have a year in industry, because I think it would be, we've kind of felt it would be dishonest, because it would suggest, with a title starting with design, that that we were guaranteed to find you a design internship. It's very difficult to guarantee design internships. I mean, no university can guarantee an internship, because we can never see how students perform in interviews, but we can give you lots and lots of practice for interviews. So for that reason, we just felt it wouldn't necessarily pass. So we have controls behind the scene, quality assurance. If students only ended up on engineering internship, would that be acceptable as a year in industry? What has happened in practice? So 2 students, they interrupted studies for a year, and they found their own internships and did those. On the plus side, that meant they didn't have, so that when you do a year in industry, you get fees, but they are maybe a third of the normal fees. So they didn't have the fees. It meant that their degree title didn't include year in industry, but when you write your CV, you can write your CV to say you had your degree, and then in the middle of this period, you went to this company. So that wasn't a problem. Is coursework required? Yes, it is in most courses. What makes it successful? So for my coding module, first of all, I need you to look at data, and you need to just understand the story behind the data. So you can't just say these are the averages, these are the ranges. You need to then understand what's interesting with this data set, so you can see what the aims of a visualization would be. And then you've got to design it visually, and then you have to code. But I don't just do, students who are ambitious make more mistakes. So it's not just better code with more mistakes gets worse marks. So I have marks on the kind of quality, but the ambition and sophistication of the code. I have marks for thinking about the user interaction. Can a user actually read your text? Can they read yellow on a black background? Can they read gray on a light yellow background? Does a user know that this is a button? Do I have to go through every page in order to get back to the beginning? Can I get back to the beginning? And then I mark on, students have to talk about the risk-taking they're doing, and they have to do reflection. For design, it's kind of quality of concept, originality, kind of quality of the iterations, the communication through sketches and the making. In the second year, there's also kind of the engineering drawings. And actually, the final product is actually only one small component. We need to see the design thinking, the synthesis of ideas. So you will, for every module, it will have a different breakdown, and we have a design, you will have the brief, the project brief, and then you'll have a kind of breakdown of the mark scheme. So sometimes they can be, this is 2 marks for this and 1 mark for this. And sometimes we have a kind of, it's exceptional, it's outstanding, it's very good, it's good. About this is the coursework that you're doing yourself. And so no, we used to interview every student and ask to see their portfolio. We stopped because of the number of people applying. And I'm the external examiner of the product design engineering degree in Glasgow. And it's amazing at art schools how much time they have to spend looking at people's portfolios and interviews, and that's time which you wouldn't be able to spend with our own students. I read, for this degree, I read every personal statement. I know the things in the newspapers say academics don't read personal statements. I do read every personal statement because I want to check it's the right degree. So I check, and I also know that there is only one DICE degree. So you might also be applying for, I don't know, architecture or design engineering or a kind of mixture product design engineering. So I know the personal statement will never be a personal match for my school, for my degree, but you know, I'm human. My child went through university, so I understand how personal statements are written. I understand how schools might kind of force you down different routes. I try to see, do you understand? It's not just a straight, you know, it's not just straight design. It's not the I want to design a car. It's not I want to design a turbine blade. It's actually thinking about a range of, you know, that there is creative design, as well as the fact that engineering and maths in their own right are very creative. Good links into industry. Well, we usually have kind of people from industry coming to talk to the students. Hasn't started this year at the moment. We've got two hosts. So the final year project, the group project, is with industry. And then occasionally, so Hackmasters has employed some of our students, either short-term or long-term, with jobs. With sometimes we've contacted industry and said, look, we've got outstanding student in this area, you know. And sometimes we get emails from ex-students or companies saying, you know, can you send this job to your students? Because I have quite a lot of my students on LinkedIn, often when there are opportunities. And sometimes it's because it's a workshop or a talk, and sometimes because it's an internship, and sometimes because it's a job, they'll send it to me and I'll pass it around the students. How do you apply to DICE? Does it have to be done on UCAS? Yeah. Yeah, so it's one of you. I think you get 5 choices on UCAS. We don't see what order you put us in. That's absolutely fine. So yes, we do it on UCAS. So CAD is used in engineering design in first year. We don't use it in first year design because when students have done it in their first year, students fix when they do CAD. They've made the decisions and the work they do into CAD, and I cannot budge a student once they put something into CAD. They've already come up with their idea and they don't move from it. If we can get you used to the idea that your first ideas are rough and actually your communication should be rough, and you sketch and you make things in paper and cardboard and then you can throw them away, that's why you don't need CAD in year 1. You may need CAD in year 2 as you get to more sophisticated design. But in year 1, I want you to really think about how you decide and reject ideas. And in some ways we relate it. So I'm just trying to think if I got one of the books on me. Oh, it's not around. But here's one. So it's either in this book or in there's another book on creativity. So they're the Kelly brothers. This is the one just with Tom Kelly, and there's another one with Creative and the Title, which is Tom and his brother Kelly, forgotten his name. So IDEO, one of the top design agencies, if not the top design agency in the world, and they give an example. They're trying to communicate with a client, and they grab a pen. And they grab, too far away, they grab an umbrella and they tie it together with tape and say, is this what you mean? And straight away you can respond to it. It doesn't matter that it's a pen. It doesn't matter that it's a loo roll or a broken pencil, but you start to communicate in form. If you jump to CAD and do that fine making, quite often people in CAD can't think in 3D. And we had an issue one year with a student who did this beautiful piece in CAD. And it had 2 flaws. One was it couldn't actually work. If he'd actually made it, he'd have realized that there were problems. Like CAD lets you CAD the impossible. And the other thing was that he hadn't, because he CAD'd in one direction, he never thought about the fact that this sophisticated sort of puzzle thing, it was interesting to kind of solve, but really boring to kind of undo. What's great about the Rubik's Cube is once you do it, it's really easy to undo. And because he leapt into CAD, he had lost that sense of thinking properly in 3D. So it is a problem because it fixes you. It's a brilliant skill to have. But to be honest, there are so many people who can do basic CAD. That's not your key employability skill. And also one of our visiting design consultants, she said, you know what, it's only when you've got lots of years experience, you do interesting things in CAD. Early on, she said, most of your work you do in CAD, you cannot use it as a creative tool. You can use it to illustrate your ideas, but it's too early. Oh yeah, so DICE students, so the design studio projects, that's all DICE students together, and some modules are DICE only. But when they go into engineering design, they're doing that alongside chemical engineering. Well, I'm assuming chemical engineering, but definitely mechanical engineering, aero engineering, biomed engineering. I think materials, but I'm not sure. And then some of the other modules, the engineering modules, material science modules, when it's group work, they'll be working with other students. So they have friends. Interestingly, not so many friends who are the other subjects. And actually, what makes DICE quite interesting, when in SCEMP week, so Skills and Employability Week, which is our week 7, the DICE students will know each other, but then there might be some mechanical engineering students sitting next to each other who don't, it's the nature of the larger degrees, I mean, throughout other universities as well, but they don't know each other so well. We'll have access to the, I don't know, my colleague is recording it. Or he said he was recording it, so you should. Oh, A-level and DT is considered a creative subject. Now, I don't mandate A-level DT because sometimes parents won't let their students do art or DT at A-level because they say, we want you to do straight sciences. Sometimes your teachers don't let you. Sometimes students panic and choose, I've heard this subject's easier. And what makes me sad is some schools, for financial reasons, have had to close their DT departments. And I would turn down some really good candidates if I said you had to. My ideal, situation is you'd have DT, maths or physics, and some other subject. But it's not, and so as a result, I should look at GCSEs and I look at your personal statement. Sometimes people talk, sometimes it's a design book they've read or an exhibition they've been to, or the fact that they're sketching. So we don't require a portfolio. It would be great, but again, some students aren't doing that. And I know this is the year that you're starting to ramp up with your A-level work. So I'd rather you focused on that. Maths, A-level maths or physics is essential. You have to have it because when you do the maths courses in the first year, they will assume that you've got these maths or physics. Partly you've got the courses, but you've got that way of thinking. Sometimes people don't do maths or physics because they don't like the subject or they're scared of the subject or they had a bad experience. And we need students to come along who are comfortable with either maths or physics. It's kind of part of their headset because it is, it has got, it's also an engineering degree. You get a BEng. Personal statement. As I said, I am sympathetic because I know you're applying for lots of other degrees. What I am looking for is some interest in creative design. As I said, sometimes people talk about things that they make. Sometimes they talk about their sketchings. And this can just be a sentence. Sometimes it's about some exhibition. Sometimes it's an artifact which has really inspired them, or a designer that's really inspired them. I'm slightly more, when it's a kind of design of drones. No, that's straight mechanical engineering. But sometimes it's actually then, but then students start to talk about, there's a user-centered focus for certain scenarios, and then that actually this is where design is really interesting when you think about what is the real problem behind it. So, as I said, because I know you're applying for 5 courses, they might be very different. So again, that's two related questions about personal statement. Because I'm the academic, I don't know how all that kind of invisible work about the recording is happening. So my colleague will have noted people who turned up. But so I don't know how you apply to this webinar. What I could do, what I might just do, if I type my answer, I don't know if it's sent to, this is my email. If you've got any questions about this degree, then you can, hopefully everyone saw my email. Then you could go and you can send me an email. Volunteering opportunities for field, it's really difficult. It's I used to run another degree in a sort of more creative area in the computer science school, and even paid internships came very late in the day because it's the nature of the creative and the design world, that often it's only last minute that they know something, and it's very, very focused. So it's almost better to start thinking of what's something. So I often say to students, compile a bug list, like everything that annoys you, write it down. And also there's a notion of kind of 5 minutes of inspiration. When you wake up and you've had a really good idea, write it down somewhere on your phone or on a sketchbook or notepad, because you'll forget about it by the time you've gone downstairs. So almost as a project in the summer, if you can't, it's very difficult to find volunteering opportunities in design. So you could set yourself a project and just work on that. How many design projects per year? So on Design Studio, in the first year, there's 4 projects, three are worth points, one's not, but all of them have to be included in your end of year portfolio. So it's 4 projects in an end of year portfolio. For second year, it's 2 projects. One's a group project, one's an individual project. So those are each a semester and an end of year project. For design, in the final year, there's 1 year-long individual project and 1 year-long group project. This year, our groups have got 4 students in each group. And then you've got various other creative group projects, second year. That's got kind of big design projects as well, but slightly different perspective. They slightly different way of looking at design thinking. Interviews, no, we used to do interviews, but they took too much time. Only design project in my class. That's quite nice. I think that shows real tenacity. It's difficult to work by yourself. So I think that makes, that's quite an interesting thing to say. You've got quite a lot of space in your personal statement. This webinar's being registered. So hopefully it's being recorded and hopefully it will be sent to you. But I don't know if you can see the chat. Again, I will just, actually, I'm not sure. So if I go right back to the beginning, I think it's got my email address, just in case it didn't show properly. There. Oh, no, have I not actually put my email? Well, if you type Karen Shoup and Queen Mary, or QMUL, if you type Karen Shoup, I'm the only Karen Shoup in possibly not in the world, but I'm the only one in the UK. There's a Karen Shoup with a B, but I'm the only Karen Shoup. But Karen Shoup, Queen Mary. If you don't find a way to find a recording, if you contact me, then hopefully, Michael's due to start the recording, but that's kind of that's kind of in his domain. And if you don't find a way of getting automatic, send me an email and I can find out from my colleague Michael. I've slightly overrun. I don't know if there are any more questions. Officially, because I didn't say that I'd answered any. It's not showing up as being answered. Okay, so if there are no more questions, so